Today we're talking about the secret numbers that reveal time, what time really is, because a lot of people want to know, what is time? Is time even real? It's a big question, and today we're going to be looking at exactly what time is and how humanity has completely misunderstood time. It's a very sort of mysterious thing. It's all around you, but it's not something that you can touch, but it's everywhere. So we're going to take a look at precisely the secret of time and the numbers that reveal how time operates. So let's get started. Now, I want to preemptively say that time is one of the more complex ideas in Hyperianism. So please keep in mind that I will do my best to explain this in an easy and digestible way. But if you want the nitty-gritty, you will have to explore more Hyperion material, such as my book on ontological mathematics, the science of the future, and of course, Mike Hockney and Stark, Dr. Thomas Stark, have done fabulous work on the topic of time in their work. And you can also see the Hyperion source in their ontological mathematics series, also gets into it as well. But let's start here by taking a look at this article, once again, from mindmatters.ai. saying, why would a purely physical universe need imaginary numbers? Now, why are we talking about this, and what does this have to do with time? Because we're going to see that in mathematics, there is a set of numbers called imaginary numbers. And imaginary numbers are something that physicists and those who are part of the materialist paradigm in general hate. They don't like them. They don't understand them, and they want to get rid of them. And the reason why, well, first of all, let me explain to you what imaginary numbers are, okay? So, and this all has to do with time, because we're going to see that most people think that time isn't real. But the thing is that humanity has completely misunderstood what time actually is. And it's not that time isn't real. It just depends on what you mean by real, because if you say time is just as real as space, so if you say time isn't real, well, space isn't real either. Distance, in the spatial dimension, with regard to just like spatiality in general, that's not real either. But if we want to say that space is real, then time is just as real as space. But we're going to understand why, if you have this intuition that time isn't real, a lot of people have that intuition. The reason why you have that intuition is because the way you've been explained how time works and what time is not time at all. So most people think of time as the succession of events. That's not time. That has to do with motion, okay? So there are three separate concepts that we're talking about today: space, time, and motion. The problem is that humanity has confused motion and time. So succession of events have nothing to do with time. Rather, it has to do with motion. Time and space is the context through which motion occurs. And that's very important. So the succession of events has to do with motion, and time and space provide the context through which motion occurs. But motion does not have to occur within space and time. It's not necessary. They are not necessary conditions for motion. Motion can also occur with respect to frequency. So you can have mental motion as well as spatial and temporal motion. We're going to explain all of this and what it has to do with the numbers that reveal this. So this is all going to come together. I know that all of this seems kind of like maybe like loose threads at first if you're coming to this information for the first time, but we're going to knit it together into a tapestry and make it all make sense. So once again, the main things to keep in mind so far is that space, time, and motion are different concepts. The succession of events is not to do with time, it's to do with motion, and space and time provide the context through which motion occurs. Also, on top of that, there are these particular types of numbers called imaginary numbers that those who believe that reality is purely physical, like most physicists, do not like and want to get rid of because they don't understand them. And we're going to see that this actually has to do with time and why humanity has completely misunderstood time. So that being said, I want to explain to you what imaginary numbers are to begin with. So if you can see this, and let me see if I can make it larger. If you are familiar with, if you took a basic math class, and most of you should, you learned about the, just the Cartesian coordinate system. And to understand, this is very, very similar, okay? This is very, very similar. Now, imaginary numbers are just a certain type of number. And what you're looking at right now is actually not the Cartesian plane. What you're looking at right now is something known as the complex plane, or an Argand diagram, or a Gaussian plane. Big fancy words, Argand diagram, Gaussian plane. But to get it, all you have to do is this axis right here, the vertical axis. You have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All you have to do to change this from a Cartesian coordinate grid to a complex plane is put an I in front of each of these numbers. That's it. Now, what does this I mean? This I tells you that it's a different type of number. Just like you place a negative sign in front of a number to show that it's a different kind of number. It's a negative number. You can have positive numbers. You can have negative numbers. You put a negative sign in front of a number to show that it is negative. There's another type of number called an imaginary number. And to show that it is that type of number, you just put an I in front of it. So the only difference between this plane and the plane that and the grid that you learned in school is that there is an I in front of the numbers on the vertical axis. So what is an imaginary number? First thing, and those Hyperions out there, especially my moderators, especially Rowan, I know you know that imaginary is the very worst thing that you could have called these numbers, because it causes so much confusion, because people think, oh, well, if they're imaginary, they're not this real thing. No, imaginary numbers aren't imaginary. It's just a terrible name that someone chose to name them. And even mathematicians have trouble, because this name imaginary causes a lot of problems. So people have actually wanted to rename them, because you have the real numbers and the imaginary numbers. And so people start to think, well, real and imaginary must mean like fake numbers or something like that. No, that's not what it means. And people have wanted to rename them, instead of real and imaginary numbers, as to, let's say, direct and lateral numbers. And that makes more sense, because you look at them as sort of directions. You have direct and lateral numbers, or even changing imaginary numbers to orthogonal numbers is another way that people have wanted to change the name to. So I just want to get it across. I'm going to call them imaginary numbers, but please, please, please remember that saying that they're imaginary doesn't mean like that they're an illusion or anything like that. It's just a different type of number, just like a negative number is a different type of number. Now, how are imaginary numbers different? Well, if we use geometry and we arrange them on a grid, you see how if you have, say, like, I think on the grid here, this is a 2, okay? 2, and then -2 is right over here. So -2 is 180 degrees away from 2. So you can look at negative numbers as being 180 degree rotations. So imaginary numbers are just 90 degree rotations. They lie in between. So what are imaginary numbers? If you have a grid and you have, your positive numbers and your negative numbers that are 180 degrees apart from each other, imaginary numbers are just the numbers that are smack dab in between, geometrically speaking. They're just in between numbers. And the reason why that we have to have imaginary numbers is because if you take, say, if you take the square root of 4, that's an answer, right? You can get an answer from that. But what if you take something like the square root of -1? Well, the square root of -1, you have to use imaginary numbers to answer that question. Because if you have a positive times a positive equals a positive, and a negative times a negative also equals a positive. So you need a number that, when multiplied by itself, gives rise to a negative number, And that's exactly what imaginary numbers do. When you take I, which is just one I, and multiply it by itself, you get -1. So you can see they're exactly like other numbers. They're just different properties where, a positive times a positive is a positive, and a negative times a negative is a positive, and imaginary times an imaginary is a negative. So they just have different properties, and you need them for mathematics to be complete. If you don't have them, mathematics isn't complete. It won't work correctly because, for example, you wouldn't have an answer to what is the square root of -1. What is it? If you don't have imaginary numbers, well, there is no answer. That's a problem. We need mathematics to be complete and consistent. And just for completeness' sake, if this axis is imaginary numbers and the horizontal axis are the real numbers, all the numbers that lie in between, there's something known as complex numbers, and they are a combination of imaginary and real numbers. We don't even need to get into that today, so you don't even have to worry about that. I just wanted to throw that out there for those who are kind of curious, like what about all the numbers in between? Those are called complex numbers. So there's imaginary numbers, real numbers, and complex numbers. But the main thing to understand here is that real numbers are what you're all familiar with, and imaginary numbers, and I'm going to say it again because people always have a hard time with this. Please remember that imaginary numbers are just as real numbers. It's just a name. Doesn't mean they're an illusion. Doesn't mean that they're fake or something like that. So let us continue. Hey, thank you, Pixie. I appreciate that. Oh, and let me also explain to you now why physicists hate imaginary numbers. And then we'll read and see how this all ties together and what it has to do with time. So in ontological mathematics, Hyperianism utilizes the system of ontological mathematics. And so in Hyperianism, we know that this is a mathematical reality. And we know that for mathematics to be complete, that imaginary numbers exist. So in Hyperianism, since reality is a mathematical, we know that imaginary numbers must actually correspond to something that exists. It's not something you can just use as a tool and then sort of delete, which is what physicists do. They'll use imaginary numbers and then delete them from their equations, get rid of them, because they don't like them. And let me explain to you why. And that has to do with the title of this article here. Why would a purely physical universe need imaginary numbers? So you see, physicists are fine with positive numbers because you can match up positive numbers to everything that they're familiar with. You can have certain lengths. A certain thing is 6 inches. A certain thing is a foot. Certain things weigh a certain amount. 120 pounds. These are all real numbers. These are all positive real numbers. And physicists are fine with positive real numbers because there are things that they can concretely correspond to. They're also fine with negative numbers because you can also use negative numbers in reality. For example, representing things like debt. You can look at your bank account. If it says, negative $2,000, it means there is a debt. There is an insufficiency that you have to pay back $2,000. So negative numbers can also correspond to things in reality, at least in their mind, even though it's sort of conceptual. So they're fine with negative numbers as well. But the question is, well, what about imaginary numbers? What would it mean if instead of having $2,000 in your bank account or negative $2,000 in your bank account, what would it mean if you had 2,000 I in your bank account? What would that? What is that? So since they can't figure out what imaginary numbers would correspond to in the physical world, they don't like them. So they use them and then get rid of them. But we're going to find out that imaginary numbers are actually correspondent to time itself. Whereas real numbers correspond to space, imaginary numbers will correspond to time. And this will facilitate motion in a contextual sense in the space-time domain. Now, let's just read on here. So why would a purely physical universe need imaginary numbers? Our computers and the entire modern world depend on them, says science writer Michael Brooks in an excerpt from his new book. In this new book, How Mathematics Created Civilization, science writer Michael Brooks offers the intriguing idea that the modern world arose from imaginary numbers. Imaginary numbers are not imaginary at all. The truth is, they have had far more impact on our lives than anything truly imaginary ever could. Without imaginary numbers and the vital role they play in putting electricity into homes, factories, and internet server farms, the modern world would not exist. So this is incredibly important to understand. Almost everything that you rely on in existence relies on imaginary numbers. So electricity into homes, factories, internet servers, quantum mechanics, all this relies on imaginary numbers. If you remove the imaginary numbers, all the equations would fall apart. And this is why physicists are, kind of confused because they don't know what they correspond to. They don't understand what imaginary numbers correspond to, so they don't like them, but they know that they need them for reality or for their equations to work. And we, as Hyperions, know this is a mathematical reality, so we know that imaginary numbers must correspond to something. Now, the problem is that today in physics, they try and use real numbers to represent time. Now, this is where they have gone wrong, because imaginary numbers are very real and they are essential to how reality works because imaginary numbers correspond to time. Physicists don't like imaginary numbers, they don't understand it, so they've used real numbers to correspond to time. Now, I lost my train of thought. Oh, so imaginary numbers, they use real numbers to correspond to time. And this is why everyone has a completely misunderstood notion of what time is. That's why people think that, have this intuition. You probably had this intuition that, it doesn't seem like time is real. It just seems like there's emotion and we've labeled it and things like this. Like a lot of people have this intuition. That's because humanity has misunderstood what time is. Time and motion are not the same thing. Time and space are dimensions that allow that it's the context through which motion occurs. So what the truth is that, and we'll keep reading to figure this out, but I want to give you sort of the background so it all kind of comes together and makes sense. Now, this is going to be a little bit of a mindfuck because you have to unlearn everything that you know about time to understand how time truly works, because it doesn't have to do with real numbers. It has to do with imaginary numbers. And so, it's going to be hard to wrap your head around this at first. I mean, if it's not, that's awesome. But if it is, don't worry. It's because it's a completely new way of thinking. So we all understand how space is three-dimensional, and it's sort of the context through which things in space occur. Now, the thing is that time is a kind of space, just like, space is a dimension. It's a dimension just like space, except where space relies on real numbers and are hence real dimensions, time relies on imaginary numbers and is an imaginary dimension. Now remember, imaginary does not mean it's unreal. We could call it a lateral dimension or an orthogonal dimension. It is just geometrically at 90 degrees to spatiality. It is just orthogonal to spatiality, to space. Okay, so saying it's an imaginary dimension doesn't mean it's an unreal dimension. It means it's an orthogonal dimension. It lies at right angles to space. So time and space are a dimension, which means that when we look at units of measurements in time, we're actually looking at distances. So units of time should not be understood how people have typically understood it. Time actually relates to distances because time is the context through which motion occurs, and you need distance for motion to occur. You need both spatial and temporal distance for motion to occur in the space-time domain, okay? So remember, I'll say it once again because I know that this is a new concept and you kind of have to unlearn everything you know about time and space and motion and have this new way of thinking about it. Space is represented by real numbers. Time is represented by imaginary numbers. They are dimensions and have to do with distances. Now, time and space provide the context through which motion occurs. It is contextually. It is contextual. Motion doesn't need time and space. There can be mental motion, and then motion is occurring through frequency. But that's a different topic. I just want to say that motion is not the same thing as time. Motion is something that occurs through time and space. You need that context for motion to occur through. I know I'm repeating myself a lot, but a lot of people have a hard time with this, and I completely understand. It's hard to grasp when you're used to thinking about it in a certain way. Here's a really easy way to understand sort of time as distance, and then motion being something that occurs within that context of space and time, right? So if you say, hey, I want to go over to Walmart, and you ask your friend, hey, how far is Walmart from here? And your friend goes, oh, 5 miles. That makes sense, right? Oh, it's 5 miles away. And then you can put yourself in motion to travel over to that Walmart that is 5 miles away. But imagine a different scenario. Imagine you ask your friend, you go, hey, how far is Walmart from here? And he goes, hey, about 5 minutes. Well, you see, now we're thinking of time, and this is just an analogy. It's not perfect, but see, now you're thinking of time in terms of distance. Now, you can put yourself in motion and travel to that Walmart and arrive after 5 minutes. So you see, space and time are contextual elements through which motion occurs. That Walmart is 5 miles, 5 minutes away, and you can put yourself in motion to reach that. So time has nothing to do with the succession of events. Motion has to do with succession of events. Time and space are the context through which all this occurs. So let's now continue here and see why physicists hate imaginary numbers. They can't understand them. They try and get rid of them, and how this all, and they completely misunderstand time as well, because they use real numbers to label time and think of it as in terms of succession of events. Now, one caveat here that I want to say, in relativity, they are actually beginning to understand to use imaginary numbers to represent time, because they're realizing that thinking of time in terms of distance and imaginary numbers actually makes things a lot easier. So I want to point that out. In relativity, even we'll probably do a whole video on that in how scientists are starting to try and kind of associate imaginary numbers with time in terms of relativity, but they don't really understand it. They just know, oh, well, it makes things a lot easier. So anyway, let's continue. I am just mentioning that again too, to say that this is an idea, in terms of relativity, that even some scientists are starting to understand. So imaginary numbers are, we recall from school, are the square roots of minus numbers. Two plus numbers, that's where they're calling them plus numbers and minus numbers, but they mean positive and negative. Anyway, two positive numbers multiplied result in a positive number, but so do two negative numbers. The square roots of negative numbers must exist, but they exist in an imaginary sense. Now that's not true. You see, even this no, stop it. They don't exist in an imaginary sense. They have nothing to do with no, that's a complete misunderstanding of imaginary numbers. They're simply numbers with a different property. You can call them orthogonal numbers or lateral numbers. You're falling for the fallacy of equivocation by saying, oh, they're imaginary numbers, so they're an illusion. No, stop. Anyway, so here's a quote from Michael Brooks. Students who might complain to their math teacher that there's no point in anyone learning how to use imaginary numbers would have to put down their phone, turn off their music, and pull the wires out of their broadband router. In other words, all this technology, your smartphone, your music player, your internet, all that relies on imaginary numbers. And for us as Hyperions, that's totally fine, because we know this is a mathematical reality. So that's fine. There's no problem for us. But for physicists who want to only rely on real numbers, they're put in a bind because they're like, well, fuck. We need imaginary numbers to make this work, but we don't want imaginary numbers to actually exist. So we're going to use them as a tool, but then say that math is just a tool and it doesn't correspond to reality. And it's just, you see, they try and like get rid of their equations. In quantum mechanics, they actually remove imaginary numbers from their equations. By the way, yeah, imaginary numbers are everywhere in quantum mechanics. You can't do quantum mechanics without imaginary numbers. They're all over the place. So is the source formula, by the way. If you go, take a course in quantum mechanics, you're going to, source formula is one of the first things you're going to learn about. Same thing with Fourier transforms, which are by like the foundation of ontological mathematics, by the way. So it's right there in front of the face, but they want to deny their existence they do things like taking the complex conjugate and whatnot, which is sort of a mathematical trick to remove imaginary numbers after you use them. It's kind of like you use imaginary numbers, then when you're done, you get rid of them and like pretend they weren't there, but you had to use them for it to work. You can't just do that. That's anyway. Physicists are not good at philosophy. So while acknowledging that a full mathematical description of nature requires imaginary numbers to exist, okay, so this is really interesting here. So, and this is where Brooks screws up. So while acknowledging that a full mathematical description of nature requires imaginary numbers to exist. So if you want to mathematically describe the physical world, you need to use imaginary numbers. You have to. You must. You can't not. You must. So if you want to make a full mathematical description of nature, you have to use imaginary numbers. Well, why? Well, in Hyperianism, obviously, this is the space-time domain. You need time because it's the space-time domain. That's why imaginary numbers are in there. So that's fine. No issue here. So Brooks considers the term imaginary numbers unhelpful. Very correct. But let's continue. Because he considers all numbers to be imaginary. Oh, my friend, there you have gone very wrong. So Brooks thinks that the term imaginary numbers is unhelpful because he thinks all numbers are imaginary. So what he's doing is, again, he's using imaginary in the term of like fake or unreal. So he thinks that all numbers are unreal. And you can see how you can have people who collect facts, but they can't understand the significance of the facts that they have collected. And that you understand that you need imaginary numbers to fully describe reality, but then you want to call all numbers fake. Once again, imaginary numbers are not fake numbers. They're just orthogonal lateral numbers. Numbers that operate in a different way, just like negative numbers operate a different way than positive numbers. Anyway, Brooks asserts, so what we're discovering here is not some deep mystery about the universe. Yes, it is. But a clear and useful set of relationships that are a consequence of defining numbers in various different ways. False. So Brooks seems to be taking, I haven't read Brooks' book, but from his comment here, he seems to be taking the stance that mathematics is just a tool that humans developed and it doesn't correspond to anything real. That is a ridiculous and utterly stupid position to take. But that's I don't know for sure that is his position, but based on that quote, it really seems like it. So let's continue here. But what does his claim that numbers are not some deep mystery about the universe leave us? Recent studies have shown that imaginary numbers, which can't really represent objects the way we can represent natural numbers by objects, are needed to describe reality. Quantum mechanics pioneers did not like them and worked out ways around them. All right. So once again, just to reiterate what's going on here. Recent studies show that imaginary numbers are required to describe reality. You cannot describe reality without them. Again, that's fine for us. But physicists don't like them because you can't use imaginary numbers. You can't correspond them to objects like one particle 3 atoms, 5 molecules, whatever, 1/2 charge, whatever. What's what does it mean for there to be I particles? Well, we're not saying that there's I particles. We're saying that imaginary numbers correspond to time. They just have missed this because they have understood time in the wrong way. They have used real numbers to define time and equated time with the succession of events, when in fact it's imaginary numbers that define time, and time is a dimension which is contextual for motion to occur through. So, and again, for those of you who had, and this is great, I see so many people who think that time isn't real. And again, the reason why you think that, people think that time isn't real, it's just motion. And that's a great intuition, because it's not entirely correct, but you're having the intuition that you have been told what time is wrong, and that is true. What you have been told time is incorrect. Motion is a separate thing from time. Time is just a contextual space through which motion occurs. So, time is very, very real, though. It's as real as space. If you consider space to be real, time is real. It's just completely different from how it's been described. So the problem that physicists have, and the reason why physicists have blundered so, is because they don't want to admit that reality is mathematical. And because if reality is mathematical, when they find numbers that they don't understand, like I, well, that's a problem for them. Because in a mathematical reality, you go, well, if you find these numbers in equations that are necessary to describe reality, they have to correspond to something. Because numbers are reality. Since numbers are reality, if you find these numbers in your equation, they have to correspond to something. But physicists don't understand imaginary numbers, and they can't find anything, can't figure out what it could correspond to. And so they hate imaginary numbers. And if they accepted that reality was mathematical, they would know that imaginary numbers would have to correspond to something. And you see, that's the power of ontological mathematics. Because in physics, if you have something like imaginary numbers, what happens? They go, oh, we have these numbers. We don't like them. Let's get rid of them. And then they go through all this trouble to try and get rid of them or work around them or replace them with other numbers, and it doesn't work and it's sloppy. But guess what? If you're an ontological mathematician and you find an imaginary number, what do? You go, oh, well, we have to figure out what this corresponds to. And then you spend your time trying to figure out how that particular number accurately represents reality, because you know that it must. So do you see the difference? Instead of spending all your time trying to delete, ignore, get around, and destroy or ignore, you're instead spending your time figuring out, what is this? How does it correspond to reality? How can I better understand it and reality itself? You see the huge difference there? One is a path of ignorance and dogmatism, and another is a path of reason and knowledge. So here's a quote, because it says, quantum mechanics pioneers did not like them and worked out ways around them, referring to imaginary numbers. In fact, even the founders of quantum mechanics themselves thought that the implications of having complex numbers in their equations was disquieting. In a letter to his friend, Hendrik Lorentz, physicist Erwin Schrödinger, the first person to introduce complex numbers into quantum theory, with his quantum wave function, wrote, "What is unpleasant here, and indeed directly to be objected to, is the use of complex numbers. Psi is surely fundamentally a real function." And complex numbers entail imaginary numbers. A complex number is sort of a fusion, if you will, of a real number and an imaginary number. So when they're saying we don't like that complex numbers are in here, the reason why they don't like it is because a complex number has an imaginary number in it. But the studies in science journals, Nature, and Physical Review letters have shown via a simple experiment that the mathematics of our universe requires imaginary numbers. Funny thing, isn't it, that the space-time domain would require time, just like it requires space. So that's how you can understand the existence of imaginary numbers. And that is actually essentially the end of the article here. And I think that the point has been thoroughly made. And this is something absolutely fascinating. And once again, it shows something that humanity has completely gotten wrong that could be easily have been fixed if they would have understood that reality was a mathematical reality. Because once you understand that reality is mathematical reality and you find these other types of numbers in there, then you understand that these numbers have to correspond to something rather than trying to ignore them, delete them, get away from them, destroy them. That is ridiculous. So here are the main highlights, because once again, time is one of the most complex. I didn't even get into the fact that in Hyperionism, there are 3 time dimensions, just like there are 3 space dimensions. So that's a whole nother topic. Because if time is a dimension, you require, just like spatiality, just like space, you require those 3 dimensions to match the 3. Okay, all right, I'm getting into that. We'll do another video on that, okay? But ignore that I even said that for now. But if you want to know more about ontological mathematics and time, there's my book, Ontological Mathematics, The Science of the Future, the excellent series by Mike Hockney and Dr. Thomas Stark, and the great video series on the Hyperion source called Ontological Mathematics, The Science of the Future, which is kind of an accompaniment series for my book that gets into it a little bit on time as well in there. But here are the main takeaways to understand for wrapping your mind around time, okay? And that is, real numbers correspond to space. Imaginary numbers correspond to time. Imaginary numbers, the word imaginary doesn't mean that they're fake or an illusion. They're just as real as real numbers. You could easily just as well call them orthogonal numbers or lateral numbers. They're simply numbers with a different property, just like negative numbers have a different property from positive numbers. Imaginary numbers do too, and they're required for mathematics to be complete and consistent. Imaginary numbers, or orthogonal numbers, are required for reality to be described mathematically. And so we have space, we have time, and we have motion. These are all different but interacting concepts. Time has nothing to do with a succession of events. Time and space provide the context for motion to occur within. It's a context for motion to occur. Easy way to understand that is like, hey, Dave, how far is Walmart? It's 5 miles. Hey, Dave, how far is Walmart? It's 5 minutes. 5 minutes away. The space-time context is provided for motion to now occur through. And it becomes easier. It's just the only reason why this is hard to understand is because you have to unlearn what you have learned about time and replace it with a new understanding of time. And it can be difficult at first, but it becomes more natural as one gets used to it. Just like understanding that this reality is not a physical material reality. It is a mathematical reality composed of flowing points and sinusoidal trajectories within this vast mathematical complex that we all exist within. So, my friends, I hope that you enjoyed this and have learned a little something more about time and the secret numbers that unlock them. I want to give a big shout out to everyone who supports on Patreon, especially Cassidy, Alana, Renaissance Fairy, Michael, Evie, Alan, Angela, and Slip Fox Socks. Thank you guys so much. I really appreciate it. If you enjoy my work, if you ever felt like you've learned something or gotten something from my work, consider supporting on Patreon. The link is right over here. You get access to our weekly secret live streams, our hidden Discord server, The Citadel, and I help you out, you help me out, we can help the world out, I can get this information out there. I really appreciate it. It's what allows me to do all my work, and it's a lot better when you have all this, deplatforming on Facebook and YouTube. Patreon helps out a lot, so thank you guys very much. I appreciate it.